So now I want to take this greatest database of all time and then show in just 15 minutes how we can use it to actually build the application in Azure, globally distributed and using all the power of Cosmos DB. And of course Pulumi. So I start simple. Let's say I'm developing a service, a microservice in an e-commerce application. I want to show a product on a web page or something like that. And I start simple. I only have two components in my application at the moment. One is Cosmos DB and one is Azure Functions, which is a serverless, event-driven service in Azure. And for starters, I just deploy it to one region here in the US. I use Pulumi for this in TypeScript, so that's how my TypeScript program can look like. I start with a resource group, which just has a name. It's like a container for resources in Azure. And then the location of that resource group is going to be defined by the configuration of my stack, so I can configure it to deploy to different regions if I want to. And then I have a resource, a component for Cosmos DB. And the important bit here is how I configure locations. You can see based on the name, geolocations, that it could be an array, but for now I just use one location and deploy it somewhere in the US. And then I need to define an Azure function for my app. And I chose to use a component called HTTP event subscription. And the cool thing about this component is I can define the code of my application right inside my Pulumi program. So I just type a JavaScript function. I do whatever I want there. And Pulumi will take care of packaging it as Azure expects it, deploying it to Azure, and configure my application exactly the way Azure wants it to be. And I just write a JavaScript function with request and response and do whatever I want there. So another cool thing there is like in the body of that function I can just use a variable Cosmos account that I just defined on the previous slide and use it as just any other JavaScript variable. I can get keys for my connection string just out of there without taking much care. And Pulumi will be smart enough to start deploying with Cosmos and getting the keys from that Cosmos account, packaging it, passing it into my callback function, package it as a zip file, putting it somewhere in storage, and then loading the function up to use that zip file. All done for me, I just write the function. So this is my first version of the application. I run Pulumi up, wait several minutes. I get a resource group, a Cosmos DB account, and then several resources which are required to run the function app. A storage account, a zip file, consumption plan, and function app itself. So now I can run it, my product page works, and I'm sitting here in the US, I'm a happy user. I sit close to the application so I'll get the best possible experience. But my e-commerce site is global, so I have customers in Europe, I have customers in Asia. And if I measure the latency from those locations, it's not going to be that great. Like from San Francisco I might get 100 milliseconds. But from Europe, from Germany or Hong Kong, I get like 400 milliseconds. If I have multiple subsequent requests, it starts to build up really quick and I get basically worse experience for the outside world. That's not what I want, of course. I want my customers to be happy. So let's make the distribution, the application distributed globally. So I started with Cosmos DB, and I will not be clicking the portal to make it distributed. I'll just change my Pulumi program. I make one extra configuration which lists all the locations where I want it to be. And then with TypeScript or JavaScript, I parse that value. I create a JavaScript array with strings. And then the other thing I need to do is to map this array into an array of objects which will be compatible to the Cosmos account resource. That's again just one call to TypeScript map function. So I do that, I run Pulumi up again, but it doesn't help. Of course, because my customer still talks to function app, it doesn't talk to my Cosmos DB account directly. So it still makes a round trip to US, and then the US function app talks to Cosmos DB. That seems to be a trivial mistake, but when your infrastructure is big, when Cosmos DB is managed by one team and application managed by other team, it's quite easy to make this mistake in a real production application. So let's see how we can fix it. Instead, I want to deploy function app into every region, the same regions that I deploy Cosmos DB. And then I want to configure routing so that users from Asia are routed to the closest location, users from Europe are routed to the closest location, and in the US, and so on. So I can take so many regions I want, I just need to copy the infrastructure and make a front-end route and choose the better one. So my plan for the second iteration of my app, I have Cosmos DB at the backend, which takes care of the hard stuff of distributing the data. And then I copy my function app n times, and I put Azure Traffic Manager, which is like DNS-based routing service in Azure, in front of it. And I say, please route it based on the nearest location. In terms of Pulumi, I already changed the Cosmos DB, so I need to change function app now. I just have a loop. I loop through locations, and for every location I create one event subscription. And subscription is going to be exactly the same, except that it's in a different location, and then it connects to a different region for the Cosmos DB. And in the end, I get an endpoint, and I need to use this endpoint to configure the traffic manager. The traffic manager, I define a profile, which is like global thing, which has DNS name and routing method. And then again, I have a loop which goes through the same location area. And for every location, it creates an endpoint in Traffic Manager. And then it links this endpoint to the proper function app, just by URL or the ID of the resource. And that's it. When I deploy, the problem is fixed. The latencies are good wherever I am in the world, or at least wherever my customers are. That's not the end. I go to my other team, and I explain what I did, and they say, yeah, we need exactly this, but we don't use Azure Functions for this. Let's say a shopping cart service is using Go, and then they package it as a Docker and put somewhere in Azure Container Instances. But they want the rest of my application to work the same. They still want to be global. They still want to use Cosmos. Maybe my pricing engine team has like 1 million lines of Java, and the application only runs in one specific version of operating system. So they have to deploy it on virtual machines, and they put it on VM scale sets. They have a load balancer in front, like public IP, all the networking, security configured. That's already hard enough, but now they have to make it global. And it's quite easy to make a mistake there. So how can I help them? Well, I can notice that there is a pattern there. I have a backend configured for Cosmos DB. I have a front end with Traffic Manager, and then I have some compute which does stuff on their own and provides an HTTP point which I should connect to. So I can make an abstraction, and as I would do it with a normal generic purpose programming language, I can create a component for this. So I can create a component which is called global app, and it's a really simple one. I can pass a resource group, a list of locations, and then like a callback function to provision the custom resources per use case. So the callback will do two things. It creates some global resources specific for the use case, and then for every region it would create a copy of infrastructure in that region. So to explain, I'll give an example. For my function app use case, I don't need any global infrastructure. I just create a callback again, and it creates HTTP event subscription. So instead of going through the loop myself, I delegate this to component, and I just have a function which creates it in one location. For containers, I guess it's not very readable, but I have two blocks here. One creates an Azure Container Resource registry, makes a Docker image, puts this Docker image in the container registry. I can still do everything inside my Pulumi program. And then I have a callback, which again uses the JavaScript closure to use that container registry and Cosmos DB account to create Azure Container Instances and configure it properly to connect to the right region, and then use the right Docker image. So in the end, it just returns again an HTTP endpoint, and that's all my component has to know. And for my pricing team, they create all the infrastructure which I cut here, but you can see that it's like a dozen of resources just to run it. But still, it's much easier than if they had to do it themselves on a globally distributed way. So a couple of benefits that I get from this. I can also evolve this component separately from my end users. So let's say I didn't need multi-write distribution for my product service because products they are not changed by end users. But then my shopping cart team asks me to add this multi-mastering capability. So I just create an extra option, and I can distribute a new version of the application of component of the library, and then everybody can benefit from it. Let's say I want to swap traffic manager with like another service in Azure front door, which is like a CDN. They have edge locations around the world, and then they get your traffic, and then it travels through Azure networks. So it might be faster for my use cases. So I just swap one service with the other inside the component. I make a new version, and then everybody who wants to use it can just update their packages, and they basically don't have to think about this that much. So to wrap it up, yes, perfect timing. So we looked at the power of Cosmos DB to solve the hard problems of distributing data around the world. And we can, but it's still not trivial to create applications which would be globally distributed and would embrace this power to full extent. So we can use infrastructure as code to do this configuration properly, written once and then distributed between multiple teams. And we can also create abstractions which would codify some best practices. And like people, not everyone will have to think of them again and again. We just share it between the teams in the company or even between the community. So if you want to know more, there is a blog post which outlines this a little bit. And there is a component on my GitHub which does exactly this. And then if you want to start with Pulumi in Azure, there is a nice schedule like that. That's the last one. So thank you, I think we are done and good for beers.